Well, thank you, everyone. Thank you for being with us. It's late, I know it's the last session, so I will try to keep it short and as enjoyable as possible. And as enjoyable as possible it can be when one goes back in time to the times where one was studying, right? And teaching also involves examinations and all kinds of bad memories, but we will stick to the good parts, I hope. So, well, one of the things we have all in common here, we have very different profiles. We're people from academia, people from industry, people who have been working with Erlang for a number of years, people who are just new to Erlang and really excited and wanted to learn everything about it. But we all use Erlang. We are all connected to Erlang in a way. And we use it as a tool for different things and from different perspectives, but it is a tool to us. And it's funny how this concept of tool is so important for humans. I mean, we almost treasure this concept. We could apply it to a number of things, but is that concept of something external to one that we use to improve things or to conquer the things that are beyond our reach usually. And we actually use this concept even to define what we consider an intelligent being, not only ourselves, and that's something that is like a milestone in history. So we consider human, the human being to become really an intelligent being when we start using tools, and then we decided that was so important that we apply that to other species as well. So we consider them intelligent as long as they demonstrate some ability to use tools for different things. But then, again, going back to ourselves, we really take this to the extreme. And we even have this saying that when you have a hammer, then most likely a lot of things look like a nail. And this should go a little bit faster, but it will come up anyway. So yeah, that's something that I was a little bit afraid of happening to me when I had this idea of using Erlang to teach software architecture. I tried to step back and say, am I seeing everything as a nail just because I have a hammer? I will try to walk you a little bit along the path that made me take the decision, and of course, the outcome. I don't have to tell you that my hammer was Erlang, of course. As our chair said, I had been using Erlang since 2001, and it was not until later on that I became a researcher on Erlang, a postdoc in Erlang. I'm now a postdoc researcher and an assistant teacher at the University of A Coruña. But I didn't teach Erlang for a number of years. Sadly, I had to teach Java, and I taught also design patterns in relationship with Java, but trying to keep as language agnostic as possible, because as Torben said earlier today here in this track, patterns are really useful things, and they help us communicate ideas, and they help us work with other engineers. And in a way, I thought that Erlang could fill in some of the holes that I thought there were in the architecture world, so a little bit higher up from the design layer in the architecture layer of our software design. And I thought that really there were things in Erlang that will help me talk to my students, and my students talk to each other and build things on top of the concepts that I wanted to convey and to translate into them. So I will go into detail right away, but the idea is, and Torben actually had a really nice slide with the concepts that you associate usually with software architecture. So you want the students to focus on thinking what's the semantics coherence of the system they want to build, and try to avoid certain things and try to reflect early on what's the ultimate goal of the system? Because there are certain architectural decisions that if you make wrong really early on, and then they're really hard to go back on. So it was quite a huge task, but as I said, I thought that Erlang could be of help. And spoiler alert, yes, it was a success story, and this talk will be the story of how this came to pass. So to give you a little bit of context, geographical context in this sense, well, this is the map that you can see nowadays in Erlang Central about, well, this it's a little bit biased because you only appear here if you registered yourself and you say, I'm an Erlang developer and I live there. So these are all people that have registered themselves. It's not an auto-discovery system for Erlangers, but you should go there, and it really helps the community to have some statistics of where are we in the world, physically, geographically. And well, as the chair said, I'm Spanish and I come from Galicia, so that will be that yellow bubble in the middle, well, in that south corner of Europe. And zooming in a little bit, yeah, this blue bubble, that's Galicia, that's the region, well, oops, the region of Spain I come from, and that's where our university is. And this is a bit slow again, but we will get there, I guess. Well, there we go. So you can see there's 46 million people in Spain. Only in this corner, we're only 2 million people. But we have some number. We have a tradition at our university. We have a tradition of working with Erlang, as I said, even before I arrived in the research group in 2001. And we could say we were really early adopters. We had a mentor that he was really keen on Erlang. He was in contact with people at the Ericsson lab really early on. And well, he, at the time, there was a study program that had one course that you could take. It was not a compulsory course, but it was all on functional programming. And one of the languages that you could learn there at that time was Erlang already. So that's the context. So we're talking about this same university where I studied, and we will see what's the situation now and why did we have to face this choice of choosing a new language for a new subject. So, well, for the university is named after the city, and for those of you who have never heard of the city, as I said, it's a small region, and the city has like 50,000 inhabitants, and we have a small university. The university has like 20,000 students. And well, this is to give you an overview of the city, and I can remove the fog with a few data about the place. So as I said, the university has this size, 20,000 students, and it has now 25. Well, the university has now. No, I don't remember how old the university is, but it was one of the few that had computer science studies from the beginning, and our building was 25 years old very recently. So this is where we are. This is where our study or where our story happens. So this. We will have to also travel to another place in Europe. You may have probably heard of Bologna and the Bologna plan that has happened in Europe recently. It has to do with superior education, with university education, and it was an agreement that many European countries came and signed, and it was meant to unify university studies all across Europe, so that it will be easier for people to travel from one country to the other and use their title, so to say, that they were recognized and they could get jobs for the studies that they had done in an easier way, and so that will promote mobility and all those really nice things that are always in the treaties and those sort of things. And the underlying idea was also that although the university had been traditionally in the upfront of knowledge and development, that somehow was a little bit lacking behind. So it was like be maybe out of date. So it was also an opportunity to modernize the university. And well, if you listened at politicians at the time, it looked at as if they wanted to, well, turn all European universities into these fast trains, and then, well, we could jump on them in any point on Europe and get to any other point. Of course, that was the nice picture, and then there were a number of problems because there was not always the budget to implement all the nice things that came with that plan. But well, but in the end, the effect was that we had to agree. Well, not that the countries had agreed, and the universities had to implement the new plan. So, well, as you can imagine, the politicians sign the treaty, and all the academics go and meet in circles and decide what they have to do. In some countries, they had to maintain the same number of years in their studies, so probably updated some courses, retired some old courses, and implemented new ones. In other countries, the problem was a bit more difficult because, well, it required either extending or cutting down the number of years that people had to study. And that was, well, that required more effort to come up with new study plans. So going back to our example, that meant, in our case, the Spanish studies, we had, well, I will try to use the British terminology, but it's not always an easy translation. That's one of the problems that Bologna tried to solve. So in our case, our teachers or professors had to migrate from the old model in which we had 1 degree that was 5 year long that you could call the university degree, and then we also had 2 degrees that were 3 years old, that you will probably call that bachelor degrees, right? So people could have one of the 3 degrees and then join or, well, match with the long one and get the 2nd degree later on. But that was where we were, and to meet the Bologna plan, we had to change to 1 single degree that had to be 4 academic years long. And the adaptation that we did in order to, well, to do this with, well, with an amount of change that we could tackle actually was to also upgrade ourselves to the different profiles that we were having demanded by the local industry or the Spanish industry, more or less. And we then ended up not having just the 4 years, but in the 4th year, people can choose a number of things. And so the results is we have 1 degree, but they have like a specialization, so to say. And that gives them a special profile, professional profile, so they say. So the wise professors in the big room came up with this sort of plan. So this is a representation of what the studies at our university are nowadays. So you can see it's in Spanish, but you don't have to read it. You just, if you pay attention at the colors, so you see all around the 5 profiles. So there's a computer science profile, a software engineering profile, a system engineer profile, an IT profile, and a computer engineer, so the hardware profile. That's more or less the 5 outcomes. And then from the core will be like the inner core is that's the 1st year, everyone gets the same. The 2nd bubble is also 2nd year, everyone gets the same. And then they spread out to fill their profiles. But in the outer ring, there's a number of things that you have to a number of courses that you have to take if you want to have a certain profile, but also there's some closeness or there's some proximity with neighbor profiles. Or you can also, there's some variation in your curricula that you can fill yourself, and you can jump and get a completely different subject from some other profile if you're interested in that. So in this whole picture, that green thingy is the architecture, the software architecture course. So that in itself, it's supposed to belong to the software engineer profile. But as I said, any other student could also have it. But the people wanting to have a software engineer profile, they have to have this course. And I could now go on and tell you all the things that we put in the curriculum of this course, but that's not the important thing. Of course, there are a number of concepts that we want to take across, and especially thinking that there are other courses in which students get acquainted with the more traditional client-server thinking, regardless of how many layers you want to put on the server side. That's something that they get in touch in all the subjects, right? So in this one, we wanted to get them familiar with other kinds of ways of thinking about this abstract structure that we have to give to our systems, to different systems that do not fall into that classical category. So we wanted them to be familiar and experiment with distributed things and peer-to-peer things, or leader-follower schemas, or publisher and subscriber schemas, and pipeline schemas. So all kinds of things of ways of communicating components to conform, to build systems in many other ways, not just the more, as I said, the more traditional one. So that was the purpose that we had in mind. And I need my next slide. Well, that's one of the theoretical parts, and then we complement. So we get across the idea of that there are many software architectures that you can think of as skeletons for your system, but none of them is perfect. So some of them fit certain problems better than others, but even if your architecture is close enough to the problem that you want to solve, there will probably be a number of things that you have to complement that architecture with to give it the availability or the scalability or the fault tolerance or the adaptability that you want to get out of your system. Maybe not now, but maybe in a few releases or maybe in a future release. But you want to be able to have, in this case, a backpack of tools in order to go down that path. So we throw a number of tactics, a number of patterns for that as well. But as we all know, you not only learn just by listening and writing down notes and saying, yeah, okay, when I have this kind of problem, I have to remember to use this architecture, and that's it. Now, one does not learn that way. One learns when one faces the problem and sits down and gets in your computer and do things. So in this context, there's when Erlang comes into the picture, and we thought, well, if we want people to go to the slide with the whole different possibilities for one given problem, and we actually meant for them to play with not only one, but maybe a few of these possibilities during a 15-week long course, because it's just half year, 15-week. Well, if we ask them to do that in, say, Java, say, C++, well, I can imagine that much of their time they're going to spend actually debugging why this thread is blocking when they don't want it to be blocked, or why that other synchronized block is causing a deadlock or something like that, right? And we as a teacher, we don't want to spend our time helping students fix that sort of problem either. We want them to face the nice challenges. So how much scalable is a publisher subscriber schema compared to more traditional master-slave, so to say? Or yeah, I want them to try for themselves those sort of to answer for themselves those sort of questions, not to be fighting with a tool. I want a tool that will help them. And so that's when the idea of Erlang as a rapid prototyping tool for the practical assignments came into the picture. And well, I probably don't have to convince you that it seemed like a good idea at the time, right? So they will be able to really handle a number of processes quite easily. They will probably be able to connect them. Well, I can now remember for you that one of the subjects in the second year core is a programming paradigm subject, which is quite broad, but at least they already know camel syntax, right? So after a couple of weeks getting familiar with Erlang syntax, they can go along themselves and start trying things. And that was the goal. We combined that with an agile approach to the subject itself. So it seemed kind of appropriate. So these are third-year students. They are 1 year away from going out in the world, and they've already heard about agile processes and all that sort of thing. But they actually see it very little because they don't work for that long. As I said, the courses are 15 weeks long only. And they usually work in pairs, so the groups are not that big, so that they don't really have a lot of team working problem, and they, of course, don't talk to real clients or that sort of thing. So what we do instead is we take the subject itself as a project. So each week of the course is an iteration, and I provide the requirements for that week. So the requirements of this week are as follows. You have to be familiar with this kind of concepts, and we provide usually online questionnaires so that they can automatically check, autonomously check if they have acquired the knowledge that they are supposed to acquire that week. And for the practical part, we also say, well, this week you have to do this and this and this for your assignment. And this might be like tutoring them like really, really closely, but we will see later on which kind of effect it had on the outcome of the subject. So we combine our classical lectures as one will take them with the Erlang part and an agile approach for that. We also combine a little bit of individual work. That's mostly at the beginning when they're getting familiar with the Erlang syntax and the Erlang constructs and well, things specific to the language. And then they have what we call the teamwork part. And for that, we force them into big groups. And big groups in this case are teams with 6 people, which, well, is far more than they are used to. And it creates a little bit of tension at the beginning because they're usually used to just call their buddy and sit with just one person, and now they have to find the time to get 6 people together. And then also to the division of work, it requires a little bit more of planning, a little bit more of thinking, because it's not just half and half, you do this and I do that. There's 6 people and they all have to do something. So that also turned out to be interesting. And then first I will let you know a few of the things that they themselves said after we implemented this schema of working. So one of the first things that they said to us, and we ran an anonymous survey at the end of last year's STEM, and a number of people said that the schema, it helped them do things that they had never done before, but that they were more challenging than they thought that they could handle. So they said things like, we dare to do things far more complex than they usually do in other courses. And they also said things like, this is killing me. No, it's not online. It's on the hard drive, but yeah, it's some kind of weird thing with the projector, I guess. Well, I was saying that they were daring to do things more complex than they thought they could do. Some of the quotes that will come up, they also said that they had never imagined that working with such a number of processes was not going to be a nightmare. That's something that will come up on the slide as well. And that they found themselves sloppy at the beginning because the functional programming was something that they had done just at a programming course. And as a most programming course, and you did probably some programming course back in the day, you usually learn the syntax, and you usually do a few easy assignments. So yeah, implement a queue or implement a tree and blah blah, but not really like a real world problem, so to say. So that's something that was different. So in this case, we were teaching a language, but for a specific purpose, and they also valued that. So the previous one was the one with the nightmare, and this is one of my favorites that comes up at the end. So I wish we had more time, because yeah, we were sloppy at the beginning, I was saying, because we had to go back to this functional programming stuff that was like sort of almost forgotten. But then at the end, in the project, we were doing really cool stuff. That was one of the things that they also were saying. And they were like, as a teacher, one of the things that gives you well, that makes you feel better is that when the course ends, the students actually don't want it to end. They want to do more. So that was nice. And one thing I don't think I mentioned is that the actual project, they have to propose themselves. So we force them into 6 people's group, but they have to come up with the idea and the architecture and the implementation of what they want to do. So here you have some of the ideas that they have come up with and they have implemented. Of course, there's always a number of games. Whenever you leave students to do whatever they want, there's a number of them that always choose to do games. And these are all distributed systems and fault-tolerant systems, so they will usually have one or a number of servers that will either create the games or wait for players to join in or spawn specific servers for new parties, those sort of thing, with a number of different kinds of games. There's also, when you teach Erlang, there's a high possibility that people will end up doing some kind of messaging system. We also had that. But we also had interesting things as web crawlers. So people at the time were doing other courses in web searching or that sort of thing, and they used the knowledge that they were having in other course, and they combined it with the one that they were having in our software architecture course, and they implemented very nice web crawlers. Also, text analysis. Some other people were having this natural language processing subjects, and they combined that with some other kind of functionality that I wanted. And then these are 2 of the ones that most surprised me. So one team decided to implement a set of, to model like a harbor and the system that would unload all the ships coming together. So you think of Frankfurt's port, for example, so something like that. So lots of ships coming up with lots and lots of cargo to unload, and a set of cranes that will get those cargo and unload it. So that's what their idea, and they modeled that, and they chose an architecture, and they reasoned why the architecture was proper for that, and they actually did the implementation afterwards. And this other one, they were simulating like a smart city, so with lots of sensors spread around the city, measuring number of cars. Of course, the measure was made up, but they were pretending to have sensors measuring number of cars in the street or number of people in a square, and then, giving information about things about that could be improved in the city. So they were really, really nice ideas. So it's one of the things that proves that if you give people a powerful tool, they will use it for interesting and powerful stuff. You don't even have to tell them what to do. They will find cool ideas, and they will be eager to work on this kind of stuffs. Now, from the teacher with the teacher hat on, from the teacher point of view, we also had an incredible kind of results. The first is that we had almost no dropouts from the course. So every person that started the course and engaged from the beginning was able to keep on track. And this is probably not thanks to the Erlang part, but to the Agile part. So from the very week, you know what to do every week, and you get an evaluation every week. And so you're giving a little bit of your effort every week. So as soon as you have invested a bit, they get well, more motivated to keep investing because they have already invested. They don't have to wait until the exam week to actually invest all their hours in the subject. And that had that really awesome and very positive result. Also, we had really no one left behind, so to say, and that I blame in the big groups. So perhaps in a group of two, you have one that really goes ahead of the other, and the other is chasing the one that wants to get to the goal anyhow. But in a group of 6, you really have to have a team effort. And if you're going to contribute in any of those ideas, in a group of 6, well, you have to really get at least the basics of what we are asking in the subject. So that's I'm really positive that it helps that no student was left behind, so to say. But not only that, if you know a little bit of how grades distribute, they usually they have this Gauss shape, and that's usually center, well, a little bit before the 5, so to say, or in the earlier on of the C, or a little bit before the C, so to say. But this I blame both in the agile thing and in having Erlang for actually enabling them, empowering them to implement their ideas, helped us to move this Gauss diagram, and so we had, of course, we had a number of very good students that got excellent marks, and of course we had a little bit lesser scores, but yeah, the mean, so to say, the average of the class was really, really good. So it was better than we expected, and it was also really, really nice. They also felt very positive about the agile process, about the iteration. So they really valued that they, at each point during the course, they knew exactly what to do. And as I said, it forced them to keep on track, not only because of the motivation that they have and the tools that they have to make it happen, but also to give them that sense of not giving up, right? And I think I'm getting to the end, so how far on time I'm? Okay. Sure. No. When this, so as I said, this the first week. So the question for the camera was when the students choose the project that they had to do in this 6-person team. So they had a few weeks of individual work to get acquainted with the syntax of Erlang, and then, so by that time we had already seen a number of architectures. We hadn't seen all the patterns and all the tactics and all the things that we can complement the architecture with, but they already at least were able to have an idea of what kind of problem could suit a certain architecture or not. So, well, to wrap up, and thank you for the question. What I ended up with is seeing myself as having a really powerful hammer in my hand. So it was not my nails that got it all smashed up, but it was the hammer that usually helped me solve a really complicated problem. Of course, there are a number of things that are still a little rough on the edges. A number of students, they said that we could skip this first few weeks of Erlang syntax problems, individual problems. They because at the end they wanted to have more time to work on their projects. They said that they wish they could start earlier. I see a little bit of problem in changing that because I need a little bit of time to tell them about the different architectures before they can actually think of a problem. But yeah, it is true that there's another way of getting acquainted with Erlang, and it's just diving in from the very early. But I'm a little bit reluctant to do that. Maybe some of you that may have come to know Erlang just by diving into it could give a little bit of insight on that. But the strongest point I want to make before I finish the presentation links with some of the comments that Katie made yesterday at the keynote. And she said that one of the things that we could do as a community was find new ways of attracting people to the community. And I think that's kind of one of the things that we have managed to succeed at with this subject and the schema that we have used to put it in practice. It's kind of a backdoor for people to come into Erlang. They come to this course, and of course they want to learn about architecture, and they do learn about architecture. There's no reason why they cannot go into the industry, and then the concepts that they have learned, they can implement in other languages as well. But their first experience has been with Erlang. And as Torben was saying, they already have this mindset in which they will think of the different architectures and the different ways of approaching problems with this model in mind. They don't know it, or they may not be able to phrase it this way, but they already think of agents and think of, well, they may call them components most likely, but they are agents and they are components that they are isolated. They share they share very little or nothing if possible. So for me, that's an excellent way of getting people into the community, just by accident, so to say. And a second side effect that was totally not intentional, but that was really nice to see was in relationship with that comment that they did, that they felt sloppy at the beginning because they were going back to a different kind of paradigm that they were not familiar with, and they felt like they were in the first year again. That helped create a very curious effect, and it was, well, that's probably a subject for another talk, but we do have a problem with the number of women in computer science. And we have, at the university in particular, it has dropped in the last 13 years, it dropped from 26% to 10%, which is really worrying, and we don't know why this is happening, and we don't really know if it's the university's fault that we are failing to attract to STEM fields the number of women that we were able to attract before, or that something is happening earlier on in higher education in high schools, but well, as I said, that's a subject for another talk. But the second nice side effect that we managed was that because they were all newbies again, there were times in which the leader of this team of 6 people would be the woman, which is something that we usually never see in other courses that we have. So you have the 6 people group, and they come to your office, and so we have this problem, and blah, blah. And you always have the people that speaks for the group. And that's usually, well, the bravest one, or the one that, that is more eager to speak. And it's usually a male that takes that role. But because with this new technology, they were all kind of hesitant again, it will happen that well, to me, it felt like the girls in this case, they felt that they had nothing to lose, or that they were in a equally level place with their counterparts, and they knew it, and it was really refreshing to see that. But as I said, the most important thing for me is that we managed to have this backdoor. And well, I think that I will leave it here, and if you have any more questions, I will be happy to try and answer them.
Thank you very much.
Thanks.
Yes, we're going to questions here.
Did your students have some stereotypes about Erlang before starting? For example, maybe somebody thought that it's a language only for telecommunications, or it's an academical language?
They did have some stereotypes, you could call them that. Not because they knew it, but because they didn't know the language at all. They hadn't even heard of it. And they automatically classified it into the box of functional programming, that kind of languages that nobody uses. And yeah, they were, I mean, during the first weeks, and when they struggled to understand again recursion, and then you explain tail recursion, and then you, yeah, those are the concepts, and they are like, oh, why do I have to learn this again, and why would I use this, and then you get some comments like people saying, why don't we use Java? We just use Java for everything. Why is this course different? But then later on they find their own answers, and that's the best way probably.
Yes, you said that the students got weekly feedback, and I would like to, if you, it would be great if you could say a bit more about that, and especially how you would be able to give individual feedback, which is then probably also relevant for the grading part.
Okay. So the feedback, as I said, we got it anonymously because we felt it would encourage people to share more openly what they thought about the course. We asked a number of things. So we asked directly, what did you like most about the way we had the course, and what did you like least, and what things you would advise us as teachers to change for the next course, and what things you would like to have different if you had the course again.
I think you said you provided the students some kind of feedback they could work on every week.
Yes, every week. So we have so at the university we use this platform called Moodle. You maybe it's a widely spread platform from university and from online teaching. So apart from having all kinds of resources there, so they have the slides there and they have links to all sorts of news that happen or blog posts that I think they're interesting and they should read. Every week they also, I set like an online exam for them. So it's a typical question and multiple choice or short text that they have to write. And that, unless they have to write something that then I have to read, it's almost automatically graded. So they come to the lecture and they read the material that I leave for them, and then they go online and they automatically check if they understood what the lesson or what the lecture of that week was about. That's their earlier feedback, so to say. And then the other feedback they got when they come to the teaching hours and the practical sessions as well. But then they also have a final exam, and at the end when they present the project, that's the 60% of their grade is their project. So that's most of their work.
Okay, we're actually out of time now.
Oh.
But thank you again very much. Another applause, and then remember to vote.
Thank you.